Hello everyone, I am Dr.B.Krishnaveni, Assistant Professor, Department of Mathematics, Aditya University. Today we are discussing about multiple integrals. In that, we are discussing today about one of the multiple integral, that is double integrals. So what is the learning outcome of today's lecture is, at the end of this lecture, student will be able to evaluate double integrals. So now let's see how to evaluate double integrals. In practice, a double integral is computed by a repeated single variable integration. Integrate with respect to one variable, treating the other variable as constant. So you all know that what is meant by integration. So now we are discussing about double integrals, in which we have double integral. In order to do this integration, we need to integrate repeatedly by single variable integration and by treating the other variable as constant. So here we are getting the cases to find out double integrals. In that case 1. If the region R is a rectangle given by R is equal to set of x comma y, a less than equal to x less than equal to b, c less than equal to y less than equal to d, where a, b, c, d are constants, then double integral over R f of x comma y dx dy is equal to integral a to b integral c to d f of x comma y dx dy, that is equal to integral c to d f of x comma y dy, that integral with respect to dy, thereafter integral a to b dx. If the limits are constants, then the order of integration is immaterial provided proper limits are taken and f of x comma y is bounded in R. Case 2. So now if the region is given in such a way that if you are getting the double integration in this form, so that means here y limits are variable limits, x limits are constants. Since the limits are in terms of x, that's what we call those are the limits of y, and the other limits are constant, which will give the limits of x. In such cases, we need to integrate with respect to the variable which is having variable limits, that's what first with respect to y. Thereafter, the with respect to the variable having constant limit, that is with respect to x. So that's what here the limits of x are constants and the limits of y are functions of x. So we have to integrate first with respect to y, then with respect to x. Now the case 3. Just as you see in the previous case, there we are getting y limits as a variable limits which are in terms of x, x limits are constants. That's what we have taken the order as first with respect to y, then x. Now the next case is we are getting x limits are variable limits which are in terms of y and y limits are constant. So in this case, first you have to integrate with respect to x, thereafter with respect to y. So hence the order of integration for this integration is first with respect to x, then y. So these were the three cases which we have to know in order to evaluate double integrals. So the case 1 is if all the limits are constants, then you can integrate in any way. And the second case is variable limits. See the variable limits to which variable it belonging to. Here y limits are variable limits in terms of x, x limits are constant, hence the order is dy dx. And the third case is x limits are variable limits which are in terms of y limits are constants, so therefore the order must be first with respect to x, then y. So here you have to note some of the points to find out double integration. When variable limits are involved, we have to integrate first with respect to the variable having variable limits, just now we discussed, and then with respect to the variable having constant limits. When all the limits are constant, the order of dx, dy determine the limits of the variable. So here what is the point they have given is, if the limits are variable limits, we need to specify which limits they are, then we have to decide what is the order of integration. That is the first note. Well, coming to the second note, if all the limits are constant means what the order given in the question, you can follow the same order and can the order determining which limits they are. So now let's see how to evaluate double integrals, that is procedure to evaluate double integrals. If all the 4 limits are constant, then follow the given order integration, either dx dy or dy dx. Here, the inner integration variable takes the limits of inner integral and the outer integration variable takes the limits of outer integral. For example, if you have taken the integration in this form, that is dx dy, with constant limits, all were representing constant limit, and here the inner limits representing the inner variable limits and the outer variable limits representing the outer variable limits. So that's the thing they are telling in this first step. Step 2. So what step 2 means? If at least one of the limits involve variable, then first check whether integration order is proper or not. So that means first of all you have to see the limits of which variable they are taken. Suppose if the limits are in terms of x means those belonging to y limits. If they are in terms of y means they are belonging to x limits. So then after deciding this, we have to integrate first with respect to the variable which is having variable limits. Thereafter with respect to the variable which is having constant limits. So that's what, whenever given a variable limits means, first of all we need to see the integration order is proper or not. Proper order means checking and following whether dx dy or dy dx order is appropriate according to the limits. Then solve the problem as usual. Now the step 4 is draw the region of integration. First use variable limits to draw the region. Then use constant limits to complete the region such that their given relationship is preserved. This sketch helps you to understand the procedure of taking limits. The fourth step is you cannot use step 4 for each and every question. Already limits are given in the question means you can follow the first 3 steps and can evaluate what is the solution is. If you are given the region of integration means then you can follow the step 4. Thereafter you have to evaluate the double integration. So now let us see the questions regarding evaluating double integrals when the limits are given in the question. Now very first question is evaluate integral 0 to 1, integral 1 to 2, x into x plus y dy dx. So here it is very clear that you can see all the limits are constants. So if all the limits are constant means you can follow the same order which is given the question itself. So in such a way that you can see this is the inner limit and belonging to the inner variable and is the outer limit which is belonging to the outer variable. So let us do the integration this with respect to y between the y limits, then with respect to x between x limits. So let us proceed. This is the given integration and it can be written as integral 0 to 1, integral 1 to 2, x into x plus y dy, then dx. So let's integrate this with respect to y first between the limits 1 to 2, that is y limits, which is equal to integral 0 to 1. Since we are integrating with respect to y means x is constant. So hence what is an integration of the first one is x into x with respect to y, that is integral dy is a y plus y integration is y square by 2. The limits are 1 to 2. Substitute the limits integral 0 to 1 x into upper limit minus lower limit, that is substitute upper limit y is equal to 2 minus substituting lower limit y is equal to 1. Then you got the above step as substituting y is equal to 2 in this 2x plus 4 by 2, that is a 2 minus the lower limit y is equal to 1, x into 1 is x plus 1 square by 2, that is 1 by 2. Simplify, 2x minus x is x, 2 minus 1 by 2, 3 by 2 and that multiplied with x which gives x square plus 3x by 2. So now do integration of this function with respect to x between the limits 0 to 1. Now we know that what is meant by integration of x square is x square integration is x cube by 3 plus 3 by 2 into x integration is x square by 4, that is x square by 2, 2 into 2 is 4. Now the limits are 0 to 1. Substitute the limits, upper limit x is equal to 1, lower limit x is equal to 0. If you substitute upper limit x is equal to 1 means the value becomes 1 by 3 plus 3 by 4 minus lower limit. What is the lower limit will be equal to? So both contains x. We substitute x is 0, the lower limit becomes 0. Since 1 by 3 plus 3 by 4 which is equal to 13 by 12. This gives the evaluation of double integration when all the limits are constants. Now let's move to the next question which is having variable limits. The question is evaluate integral 0 to 5 integral 0 to x square x into x square plus y square dx dy. So now if the variable limits are given means first of all you have to see whether the order of the integration is proper or not. For that sake, first of all you have to identify the limits to which variable they are belonging to. So here variable limits are in terms of x, that means those are representing y limits. So obviously the other limits which are constant belonging to x variable. So hence here you can see the limits are in terms of x, so hence these are y limits. The other limits are constants, obviously they are x limits. So hence the variable y is having variable limits, hence we need to integrate this with respect to y first, thereafter with respect to x. So that's what the order of this integration is changes to dy dx. So let us do the integration in this order. Integral x is equal to 0 to 5. Now integrate the inner integration with respect to y. X constant here, x cube into integral dy is y plus x into y square integration is y cube by 3 and y limits are from 0 to x square into dx, which is equal to integral 0 to 5. Doing the limits or substituting the limits, the upper limit y is equal to x square here, x cube into x square is x power 5 plus x into x square whole square, x cube whole square, so which gives x power 7 by 3. So which is equal to, now do integration with respect to x, x power 5 integration is x power 6 by 6 plus here x power 7 integration, x power 7 by, that is 8 by 8, 8 into 3 is 24. Now the limits are from 0 to 5. So here also the upper limit only exists, the lower limit is 0. So next integrating with respect to x, x power 5 integration x power 6 by 6 plus x power 7 integration is x power 8 by 8, 8 into 3 is 24 and the limits of x is from 0 to 5. So substitute the upper limit x is equal to 5, the lower limit x is equal to 0. Substituting upper limit x is equal to 5, that is 5 power 6 by 6 plus 5 power 8 by 24 and if you substitute the lower limit, both contains x, that means lower limit is 0. After simplification, you got the value is equal to 29 into 5 power 6 by 24. Now the next question which contain the variable limit only. Now the limits are in terms of y. So y in terms of y means those limits are x limits. The other limits, that is 0 to a, is y limits. In this question, x limits are variables, y limits are constants. Hence, we need to integrate. So this is the question in which you are having again variable limits. So here you can see the limits are in terms of y. So that means those are x limits. And the other limits are constants, which are y limits. Hence, the order must be first with respect to x, then y. In the given question also, they have followed the proper order only. So hence, let's start the question with the same order, that is integral 0 to a, integral 0 to y, xy dx dy. And here y is equal to 0 to a, we have separated y variable, integral x is equal to 0 to y, x dx dy. So first let's integrate the inner part, integral y is equal to 0 to a, y into x integration is x square by 2 between the limits 0 to y dy, which is equal to integral y is equal to 0 to a, y into, or substituting the upper limit, y into y square is y cube by 2 dy. Doing integration with respect to y, we got this is equal to y power 4 by 4 into 2 is 8, where y limits is from 0 to a. Now substitute again y limits, upper limit y is equal to a, that is a power 4 by 8, lower limit is 0. So hence the answer for this question is a power 4 by 8. Hence we discussed all the types of problems in double integration that are having constant limits, having variable limits, which is in terms of x. That means they are y limits, the order will be dy dx. The limits which are in terms of y, those are x limits, in that case the order is dx dy. Hence we got in this lecture how to evaluate the double integrals when the limits are given. Thank you.